Garbage collection is the essential process that helps manage memory and prevents memory leaks in your Java programs. When we allocate objects on the heap gets a bit fuller. A healthy application has enough heap memory available. In order to keep having enough heap memory available, the objects on the heap will have to be removed when they're no longer necessary. Garbage collection's main purpose is to automatically reclaim memory occupied by objects that are no longer in use. This process is performed by the Java garbage collector, which takes care of handling the memory management. The garbage collector removes elements that no longer have a connection to the stack. In this example, memory location 100 and 102 have a connection to the stack. 101 can be removed because it no longer has a connection to the stack. Another situation is possible as well. Let's assume the method called repair holds the reference to a car object. When this method is done executing, the frame gets removed from the stack. And this can have the implication that an object on the heap becomes unreachable from the stack, because no references are stored to it anymore. The objects then become eligible for garbage collection. And they can be removed by the garbage collector. This figuring out which objects no longer have a connection is not as easy as it seems, because you don't want to freeze the entire application to figure out which objects have a connection and remove all the others. At the same time, not freezing it might make the scanning a bit more hard, because it might be possible that this object on the heap that we think has no connection to the stack was recently added. Java has smart tricks for this. These are the garbage collection algorithms. There are various garbage collection algorithms, such as the mark and sweep algorithm, the copying algorithm, and the generational algorithm. Each one has its advantages and disadvantages. To monitor garbage collection, you can use tools like Visual VM or the Java Mission Control. And to improve the performance, you can adjust heap sizes, select the appropriate garbage collection algorithm, and set garbage collection parameters that best suit your application's needs. This is called GVM tuning. And even though you can do all this, you cannot, from the code, trigger garbage collection. This is really something that the GVM decides upon. If you're ever in the position that you need to optimize an application, you'll need to know more about the different algorithms and the tuning. For now, you'll be just fine with the defaults and understanding what garbage collection is. It also helps to understand two common problems that can arise. These are the stack overflow error and the out of memory error. We'll cover them in the next video.